Hello everyone, I'm Yorgos. I work as a software engineer, and whenever I sit down to write new tests, I run into the same questions. Should I mock here or not? And if I do, which kind of test double is the right fit? To answer that, let's start at the beginning. What exactly is a test double? Well, just like actors don't perform every dangerous scene by themselves and stunt doubles step in for them instead. Okay, maybe that's not true for Tom Cruise. He does his own stunts usually. In the same way, we use test doubles in place of real objects. They take the risk for us, making our tests faster, safer, and more predictable. Without them, our tests get tied to real services and environments, and that's when things become slow and flaky. Having said that, let's take a look at the different types of test doubles. We have mocks, stubs, fakes, and spies. All of them can replace objects in our code, but each one serves a different purpose. And in fact, they can be used together as well. But what is a mock? A mock is a type of test double that stands in place for real objects in our code. It replaces the original object with one that we can control the behavior of and allows us to track the interactions with the mocked object. In Python's built-in test framework, there are two foundational classes that create mocks, mock and magic mock. Now, let's have a look at some features of the mock class. We can call any method with any argument, and the method exists automatically, while the return value will be a new mock. If we call the same method again, we can assert all of them at once. Just be consistent in mixing arguments with keyword arguments in call assertions. You have to assert them the way they were called in the exact order. What is the difference between the two though? Magic mock supports magic methods. So let's see an example. Suppose we want to use the object in a with block. In order to do that, our object needs to define the context manager protocol. This means it needs to define the enter and exit, at least, which are magic methods. However, mock objects do not do this automatically. As we can see in the right column, our snippet fails with a type error. We have to use a magic mock if we are going to call magic methods in the code we test. And this is not, of course, limited to with blocks. It might as well be other special methods like length. Should the object we are trying to test behave like a sequence, a list, or a tuple? But how to actually replace the real object with a test double? In the case of a function that owns a dependency, we need to use mock.patch and patch the imported name where the dependency is being used. For example, read file owns the file IO dependency, and it is responsible for opening and closing it before reading from the file. In the left column, we patch it, and by default, mock.patch replaces the object with a magic mock. But you can also provide your own mock object with a new argument. Note that patching globally at the place file IO is defined does not work. Why is that though? Well, when we import file IO from the IO module, inside our example module, we bind a local reference to the name file IO. Secondly, our patch targets the global file IO name, but read file uses the local reference already, so it won't capture our patch. To fix that, we would have to do lazy importing, which would have called our patch before importing our example module. Or we could have to reload explicitly. Both of them not a good practice usually. But there is a better way. In what other ways can we replace a dependency? In this example, we call read file. The implementation simply returns the contents of the already opened file. Notice that read file does not own the file IO object, it just operates on it. When a function accepts its dependency as a parameter, there is no need to patch. Instead, pass a mock object in place of the dependency. In the test, we create a magic mock with a spec argument. The spec makes the mock strictly follow the protocol of the file IO class. That's why calling an arbitrary method on it raises an attribute error. The mock only allows real file IO methods. If we can't inject, we patch, as we saw earlier. Besides decorators, we can use patch as a context manager. And patch object is also handy when the module is already imported and we patch its attributes directly. Just like the decorator lives for the duration of the wrap function scope, the patch lives for the scope of the with block. We can use the autospec flag to have the mock automatically deduce which protocol to follow. As of now, we have covered mocks, but what is a stub? How does it differ? Well, stubs provide canned responses, helping us test outputs or control intermediate results. Mock and magic mock, the usual suspects, can be used to provide these results for functions that we expect to be called in our unit. In our example, this function is called SUMMethod. One way to set fixed responses is to set the return value. This way, every call will always return some value. In the case of repeated calls with different return values, we can provide an iterable to the side effect attribute. Finally, to test against errors, we can use side effect to raise exceptions like a value error. Let's see an example. We have an in-house authentication library with a function called authenticate. It goes off to some remote service and gives us back a token. It takes an account ID that's required and an optional resource ID. The idea is that sometimes we want a generic token for an account, but other times we need a token specific to a resource, like, let's say, storage service. Our utility function, getHeaders, takes this configuration, calls authlib.authenticate, and uses the return token to build a dictionary of HTTP headers. We include the token in the authorization header of our request along some static headers like content type. When testing getHeaders, we need to make sure to replace authenticate with a test double. What type of test double to use in this case? Let's look at the left column. We may be tempted to just stub authenticate by fixing its return value to a dummy token string. This test has full coverage and it passes. But if you recall authenticate's signature, in fact, we didn't actually propagate the resource ID that we got in the configuration object. Our unit test would still be successful, but we would totally miss the link between resource ID and the generated token. To fix that, we can use mocks to also assert the arguments of the call to authenticate. Now, if we forget to pass resource ID, the test will fail, alerting us to the bug. So we use mocks and stubs in synergy in this case. Do we have to always use stubs? And what is a fake? A fake is a working implementation of a real object. but simplified for testing. Unlike stubs, you don't have to predefine return values. The fake behaves like the real thing, just without the heavy parts. This means no network calls, no file I/O, and no external services, but still with realistic behavior. Let's see again an example. On the left, the real storage client. Let's suppose it follows the mapping protocol and behaves like a dictionary with getItem and setItem magic methods. It also supports the context manager protocol. As we saw, this means that it has enter and exit as well. And it talks to a real service with implementation methods provided by storage provider base class. On the right, the fake storage client just uses an in-memory dictionary instead of connecting to the real thing. This keeps implementation lightweight, avoids maintaining stub states, and makes tests faster and more reliable, while being close enough to production behavior. Let's suppose we need to build a more complex storage client with serialization and chunking due to some practical network restrictions. Let's also suppose we cannot modularize the code further. So we have the saveObject function that takes a storage client, a key which will be the name of the object inside our storage, and the object which is the dictionary to be saved. Next, we serialize the dictionary to JSON format and we encode. Now we have the serialized data and we need to chunk them based on the chunk size parameter. We also keep track of the chunk's length to help us during reassembly. For the load object, we accept the storage client and the key of the object. We need to reverse the operation, so we first retrieve the number of chunks. Then we assemble the chunks in a bytes object. And finally, we decode the bytes and load the JSON string. But we also need to test this. Would stubbing be a good choice here? Well, stubbing can easily get complicated in this case. For example, we need to re-implement the chunking logic of the real solution to produce the intermediate stubs for the serialization and deserialization. What's more, we need complex logic for setting the individual chunks and the chunk length. I have omitted them for brevity, but these would be several lines of implementation. And you can imagine how convoluted this can be, maintaining the stubs after a few iterations. If we need to add a new step or change the serialization step, for example, for a compression step, this would be complicated pretty quickly. A fake storage client comes to the rescue as it provides a drop-in lightweight replacement for the real storage client. And we don't even need to replace it via a patch since we use dependency injection. We just test the round trip. No need to maintain stub states. If we also want to track the calls to the fake's getItem method, let's say to assert we retrieve the chunk's length and didn't accidentally hard-code it inside the fake, we can wrap it with a magic mock. Now, what is a spy? A spy is a test double that wraps a real object instead of the fake object we saw previously. Unlike a stub or a mock, it still runs the real implementation, but we also get to track interactions. In Python unit test, we can create one with mock or magic mock again using the wraps argument. Here's an example called $converter, which has some static exchange rates. When we call convert $10 to euro, the spy runs the real logic and returns 9, just as expected. At the same time, because it's also a mock, we can assert that the method was called once with the right arguments. Well, this brings us to the takeaways. So far we covered mock that verifies the behavior, stubs that control outputs, fakes that are working minimal replacements, and spies that wrap real code for inspection. A few more things to have in mind. Well, prefer magic mock over mock unless you are sure you don't need magic methods. Use autospec or spec to make the mock strictly follow the real objects protocol. Prefer dependency injection over patching when possible. Use patching when you interact with third-party code that is not modular and you can't inject the objects yourself. If you need to patch where the dependency is being used. And in unit test, mock and magic mock can be used in a way that combines all types of test doubles to achieve completeness. Thank you very much. I hope you got something from this talk.